Welcome to another class with me, Ming, and today we talk about integrating factors. Integrating factors is basically a technique you apply when you have a differential equations of this particular form up here that you see here. All right, dy dx plus px with a singular 1y and a function of x in here. So what does the integrating factor does? Well, the idea here is to change the left-hand side here, this part, left-hand side, into a form such as the one in blue. This is basically the form of exact differential equation. Basically, if you get this form, then you can this is basically the result of taking the derivative of a product of x and y. Right. So now if you have this, then this is what I can do. That is, the integration of this thing in blue here will give me fx of y plus c. That is, give me the function x and y as part of the inputs into this particular function. This is the idea that we're trying to get. So how do we get started? Well, let's get started by assuming that there is actually an integrating factor. And suppose this integrating factor have this particular property. That is, when you multiply through this integrating factor, right, you will actually get an exact differential equation. So this is actually an exact differential equation, and we call it 1 out here, all right? And next, what that means is that if you actually integrate this thing over here, it's written here again in black, we will get ixy, that is the product of a function in x and y. So the derivative of xy, that is the product of the integrating factor and my y with respect to x, will actually get me this. That is, take the derivative of y with respect to x, keeping I constant, all right? And then take the derivative of I with respect of x, keeping y constant. So with this, what you're going to obtain is that here I have two equations. Now, this is equation 2 and equation number 1. And you basically see that this thing in 2 must actually is actually the same thing with 1. So by comparison, you see that the first term in both equations are exactly the same. And the second term must also be the same. But they are almost the same, right? It must be all the same. So this is ix px times y equal to I dash of x, that is this, I dash is this, di dx, right? So p itself must be the ratio of the derivative of I over ix. Now, at this stage, you can find out, well, what is my integrating factor? Well, in order to find the integrating factor, I need to integrate both sides with respect to x. So the right-hand side just means that I'm going to get the natural log of I of x and plus c. And here is the integration of p of x dx. Now, you can get c can be anything. So it is customary to set here, the c here, equal to 0, so that we ignore the c, all right? Then this is what I have. Natural log of ix is equal to integration of pfx dx. Therefore, ix by itself, the integrating factor, must be e raised to the power of px dx. So this is my integrating factor. All right. So let's look at an example. Here, I have an example.